In this lecture, we will move even further toward a cognitive science of psychology and further away from, again, what B.F. Skinner famously referred to as a descriptive science of human behavior. And that movement invariably takes us from the environment back inside the organism and with a concern for internal processes of an essentially cognitive and, as I say, an essentially mental nature. Now, I mentioned in a previous lecture that one does this with trepidation. You can't go through a half-century of an influential, empiricistic, behavioral psychology and not show some shame when you start talking about the mental life of the animal kingdom. In fact, we show some shame even when we talk about the mental life of human beings. So let me address this issue head-on. The issue, after all, is finally the issue of anthropomorphism. And the issue of anthropomorphism cropped up with some intensity as a result of the writings of Charles Darwin. Darwin's Origin of Species was a landmark work in biology. It was also a landmark work in psychology. And it was followed up a little more than 10 years later. Origin of Species came out in 1859. 1871, 1872, Darwin served up The Descent of Man and The Expression of the Emotions in Animals and Man. And these were two heavily psychological works in which all of the implications of evolutionary theory as regards psychology were developed and defended. And this, of course, caused quite a ruckus, because Darwin was claiming that there really were not qualitative distinctions to be made between and among the psychological processes of human beings and other animals, but that instead these psychological processes took place on a continuum, and what you found in human beings was just a more developed or advanced version of what was also present elsewhere in phylogeny. So the argument was then that we are not unique in being rational or unique in being intelligent or unique in having verbal abilities and the like. Rather, we had a more developed, a more sophisticated version of this than we would find in other animals, but that you would find symbolic modes of communication throughout much of the animal kingdom, not unlike linguistic functions, and that indeed all of the animals displayed great intelligence and intellectual agility in solving the kinds of problems unique to their species. We were very, very good at adapting to the environment in which we would have to live. Other animals had to be very good to adapt to the environments in which they lived, or they wouldn't be here. Well, this gave something of a license to students of animal behavior, such as George Romani's, something of a license to begin to understand the complex behavior of animals in human terms, and to speak of animal intelligence and animal rationality and problem solving and so forth. Now, I should say that this did not begin with Darwin. In fact, these so-called anthropomorphic tendencies, let me pause for a moment to define what I mean by that. To say that an explanation is anthropomorphic is to say that a non-human animal's performance is being explained as if it were based on something that takes place in human beings when they behave that way. So if I see some shocking scene and open my mouth wide and raise my eyebrows, and if there's a rhesus monkey who confronts some odd object, the picture of a snake and the like, and the rhesus monkey's mouth opens wide and the eyebrows are raised, we would say that the rhesus monkey is now affected by surprise and concern. That would be anthropomorphic, because if you asked me why when I saw the snake come out of the grass, I gasped, opened my mouth and raised my eyebrows, I would say, well, I was surprised and alarmed by this. So in taking some human mental state and applying it to a non-human organism for the purpose of explaining behavior that looks something like the human version and is in some important respects equivalent to the human version, is said to be anthropomorphic. Now I say, Anthropomorphic tendencies in explanation are as old as explanations of animal behavior are. Aristotle is everywhere anthropomorphic in his account of nest building and fish traveling in schools. Aristotle tells us that man is by nature a social animal, but he also goes on to say, so are swans and bees. Now, the explanation he's going to have for the social affiliations of the human community will be different from the basis upon which swans and bees become socially affiliated, but nonetheless, where Aristotle, or any of the ancient naturalists, he was the first great one, but many came in his patrimony, all of the ancient and then the modern naturalists routinely explained animal behavior by matching it up with what would seem to be human equivalents and assuming that something similar must be going on. If there was hostility to this sort of scheme for explanation, it came from several quarters. First, there was the growing tendency within scientific circles to avoid speculation. That is to say, when science and philosophy began to part paths quite systematically, and this is chiefly in the 19th century, and chiefly as a result of what might be called the romantic criticism of science, initiated by Goethe and including Schiller and Herder and Schelling and famously Hegel and the like. I say when that philosophical critique of experimental science hit its stride, the scientific community responded predictably by attempting to eliminate from scientific discourse anything smacking of philosophy, not to mention religion, not to mention what generically was referred to, and I think rather clumsily referred to, as metaphysics. I mentioned the great influence that Ernst Mach had on B.F. Skinner. Ernst Mach, late in the 19th century, was among the leaders of thought in the developed sciences, that science will progress in proportion to its ability to rid itself of its ancestral philosophical and metaphysical baggage. It should stay at the level of systematic description and measurement, direct observation, and it should leave armchair speculation to people who have a stomach for that sort of thing, namely metaphysicians. Well, I say, as that frame of mind set in, of course, one of the casualties would have to be an anthropomorphic approach to explaining animal behavior. In fact, Ernst Mach, in one of his influential works titled The Analysis of Sensation, even raises the question whether we should attribute mental states to non-human animals, and says the only time you would do this is if there really were absolutely no other way of accounting for the behavior. But you certainly wouldn't begin with an assumption like that. You would invoke the anthropomorphic language if there simply were no other way of rendering a coherent and intelligible account. And you can tell from the way Ernst Mach is discussing this that he is not inclined to think there will be such instances indeed once you get the story right. Many, many years later, B.F. Skinner will be satisfied that he has got the story right in the behavior of organisms, and he will issue a broadside against all anthropomorphic tendencies. He not only doesn't want us talking about animal minds, he doesn't want us talking about minds at all. Now, between Ernst Mach and B.F. Skinner, or I should say between Charles Darwin and B.F. Skinner, there are developments that will tend to oppose anthropomorphizing in what we now call the behavioral sciences. George Romanes was a very, very important disciple of Charles Darwin's. He was a fellow of the Royal Society. Today, I think the kind of work he did would be described as ethology. And he wrote lengthily on the psychological characteristics and achievements of non-human animals, doing this strictly out of a Darwinian framework. And with Darwin, discussing animal intellectual, perceptual, and psychological processes as lying on the same continuum with the human processes, and thus permitting himself the luxury, the pleasure of anthropomorphic types of explanation. Now, Romanes was a very sophisticated student of science, and so in his important work, he addressed head-on this question of anthropomorphism and said, you know, you've got to avoid being excessive here, but you also have to avoid what he referred to as reverse anthropomorphism or inverse anthropomorphism. That is, where you struggle so desperately not to attribute any human characteristic to a non-human animal that in fact you end up with no explanation at all. You simply haven't come to grips with the actual form of life that animal is living, and in an attempt to rob that creature of any characteristic that it might have in common with us, you're actually stripping it of characteristics it actually does have. So I want to make the record clear that Romanes was not ignorant of this issue, and he did address the issue, and I think what we might say is that he settled it on the side of a somewhat conservative anthropomorphism. Well, textbooks often tell us that Romanes was undone by a much more up-to-date, modern, clear-headed psychologist, a psychologist of our own persuasion, so to speak, C. Lloyd Morgan, Conway Lloyd Morgan. And I say there are textbooks that make it appear that Lloyd Morgan was in a running battle with George Romanes. I should point out that Morgan's chief work was dedicated to Romanes. He was a great admirer of Romanes. But it is the case that Lloyd Morgan, in his writings on animal behavior, not only raised the issue of anthropomorphism, but provided fairly telling arguments against that tendency. He's building a bridge, you see, that will lead us to a Skinnerian behaviorism, and he serves up what is often referred to as Lloyd Morgan's canon, or Lloyd Morgan's maxim. It's a throwback to Occam's razor. What Lloyd Morgan's canon says is essentially what Ernst Mach was saying, namely, you only invoke those principles and processes absolutely essential to accounting for the event you're observing. You don't bring any more psychology or mental life or human characteristics into your explanation of animal behavior than the actual facts of the behavior require. So it's not just a conservative anthropomorphism, it's really quite an anti-anthropomorphism. And to some extent, this prevented us in experimental psychology from studying the sorts of things that animals actually can do, that non-human animals actually can do. It was largely as a result of Curler's studies of insight in the great apes that psychology started to come back on the air to rejoin the traditional ethologists going back to Aristotle and to concerning themselves with the remarkable, yes, I will use the word, the remarkable intellectual achievements found throughout the animal economy. The achievements that can only come as a surprise to people so metaphysically committed to an anti-anthropomorphic philosophy of science as to be astounded that animals can do these things. Well, where do I want to pick up the story? And it's a story that will lead inevitably toward the cognitive revolution that we are supposedly now in the middle of as the 20th century comes to an end. Let me pick up the tale at the University of California at Berkeley, and this even while B.F. Skinner is still a graduate student. This is even before Skinner's Behavior of Organisms. Let me pick up the tale with a psychologist who did any number of fascinating studies, a psychologist by the name of Edward Chance Tolman, T-O-L-M-A-N, E-C Tolman. One can only wonder what the young men and women at Berkeley must have thought as they walked up and down the halls of that building at Berkeley where Tolman's studies were going on. Imagine them looking through a little window and peering inside the laboratory in which Tolman had his experiments being conducted, assisted ably by his research associate, Blodgett. You could go in one day. I sometimes imagine a major in English literature sort of wandering off course and showing up in the psychology department at Berkeley. Let's say on a day when that English major is supposed to ring up at home and tell mom and dad how things are going at Berkeley and what it's like to be at a major university, and peering in through the window and seeing something like this. Tolman, or more probably Blodgett, wearing a white laboratory coat, stooped over with each hand on a very, very small wheelbarrow. A wheelbarrow maybe 10 inches long, strapped inside of which we find a white rat. And I mean strapped in as if getting ready for major surgery. So there's the rat, wide awake, on its back, to use Sir Thomas Browne's expression, staring about with a gross rusticity, and there's E.C. Tolman or Blodgett, not only holding this little wheelbarrow, but walking around in some very odd path, just walking around this way and that way and this way and that way with a rat strapped into the wheelbarrow. Can you wonder what that youngster would say, ringing up home that evening, when asked the question, "Have you met any members of the Berkeley faculty? Do you know what it is they do? It's a very famous faculty. What kinds of things are done there?" And stammering into the phone, "Well, unless I'm gravely mistaken, one of the most famous ones seems to be wheeling rats around in a wheelbarrow." I'm sure if it happened at Georgetown, an immediate refund would have been demanded, and quite plausibly so. Well, actually, Blodgett and Tolman were not wheeling these rats around aimlessly. They were wheeling the rats around in a maze. They were wheeling the rats through the correct solution path of the maze. The right pattern of left and right turns, right, left, left, right, left, over and over again, wheeling the rats through the maze. And then what they would do is this. After each rat had been thus wheeled through the maze, and by the way, wheeled through the maze how many times? Wheeled through the maze about the number of times that other rats allowed to run the maze would have to run the maze in order to learn the maze. Achieving that number for their little rats in little wheelbarrows, Tolman and Blodgett would then put the rats actually in the maze. And lo and behold, what would the rats do? They would quite spontaneously, quote, solve the maze. What was quite clear is that in being wheeled through a maze, you were learning the maze. Tolman did not find this at all astonishing. In fact, he would often describe this as akin to being driven home by the same path, by the same driver, day after day, where you're never actually at the wheel, you're not turning the wheel, you're not engaged in any of the behavioral or motoric events associated with getting from A to B, but you are being stimulated by pattern stimulation very, very reliably day after day, and you're learning that this comes after that, comes after that, comes after that. All it takes for the learning to take place is not the deliberate application of rewards, not the connecting of specific motor events with specific stimulus events in the environment. No, you're a creature of sufficient complexity to be able to learn by experience. The right model of learning, then, is not a stimulus-response sort of mechanical learning. It's much more a stimulus-stimulus kind of learning, learning what goes with what. In fact, Tolman used the idiom sign significate, not significant, but significant learning, that what is established as an association between certain environmental signs and what those signs actually signify. And once you've learned that this turn, that turn, this turn, that turn ultimately yield the goal box, well, then you run it. And all you have to do to learn that is to be exposed to it reliably. You don't actually have to run through it. Nothing motoric is required. Tolman did other studies. For example, rats have learned a maze. They've learned to run through the maze correctly. Now you flood the maze. And you drop the rats in a flooded maze. Now, it surely will come as no surprise to anyone in the audience that a rat who has thoroughly learned to run a maze, when plopped into that same maze, will swim it correctly also. But this must be an embarrassment to a mechanistic, behavioristic psychology that assumes that what learning is the connecting of specific responses to specific stimuli. Because, in fact, the running responses of a rat, in musculoskeletal terms, are radically different from the swimming responses of a rat. So if what learning involved was tying a particular motor event to a particular sensory event, then having learned to run a maze should give you no advantage when it comes to swimming a maze. So there's another little Tolmanian contribution to the cluttered thought of the experimental psychology of animal behavior. Well, let's take another Tolman study. Now suppose you've got these rats and they've quite successfully been running mazes. You drop them in the start box and they proceed without error to make just the right pattern of left and right turns until they get to the goal box where they have themselves a little meal, and that's a day's work and a day's wage. Now what you do is this. You take the rat out of the maze and you close the lid of the maze. And now you put the rat not in the maze, but on top of the cage. Now, if you really were a hopelessly mechanistic stimulus-response psychologist, what you would predict the rat would do is this. Standing on top of the cage, the rat would proceed to make these left and right turns that just constitute solution to the maze. The rat would repeat on top of the cage the behavior that was successful when inside the maze itself. This, I should tell you, would be evidence of the dumbest rat in Christendom. What the rat does is, I would say, what any non-mechanistically oriented psychologist or mere mortal would expect. The rat makes a diagonal beeline for where the goal box is. Do you see? Just starts at the start box, Tolman puts him down, and the rat just tears off to where the goal box is. He tears off to where the goal box is because, if this expression will be excused in polite company, he knows where the goal box is. And the reason he knows where the goal box is, Tolman says, is because in the course of learning, he has formed something called a cognitive map. Now, Tolman is among the first in 20th century psychology. This is all taking place in the 1930s and 40s and 50s. Tolman is using cognitive here in a way that we're going to come to use cognitive. Cognitive referring to some internal representation of the external world. What learning is all about, on this account then, is developing the right kind of representation. It's a representation the organism then can work on to solve problems. Not unlike what Curler finds in studies of insight, for example. Well, the question that naturally arises then, the question cropping up from these studies, is what the role of reinforcement and reward must be. Tolman does this study now, particularly interesting study. Suppose you take experimental animals and in the customary way you deprive them of food for 24 hours or 48 hours. You then put them in a maze. If they get to the goal box, there's food in the goal box, and there is then a successive improvement in performance. That is, the animals make fewer and fewer errors day by day by day until finally they go through the maze errorlessly. They have, as we say, solved the maze. There's no surprise in any of this. Practice makes perfect, and as behaviorism predicts, it is rewarded practice that makes perfect, so the application of reinforcement has established maze learning. But Tolman does this wrinkle on the standard experiment. Some animals are allowed to eat for an hour before the training session. That is, they eat ad lib. They have a free access to food, and in less than an hour they'll fill themselves up. They eat to a point of satiation. Thus satiated, the rats are then put in the maze. And by the way, there isn't any food at the end either. Now, what does the fully satiated rat in a maze do? Well, actually, rats are active organisms, and so the rats will roam around in there. They might be a bit bloated from a heavy meal, but they make their little left turns, they sniff around, they do this and that. Now, each rat is given this treatment on a regular basis for a period of a week. Note what the treatment is. The animal has ad lib access to food. The animal is then put in a maze and is left in the maze for an hour and is then taken out of the maze until the cycle repeats itself. Meanwhile, there is another group of rats given exposure to the customary procedures. Deprived of food, put in a maze. If you get to the goal box, you get food. And this goes on for a week. Now, rats in the latter condition show progressive learning. That is, their errors decrease day by day by day. Rats in the previous group show no reduction at all. As you might guess, their error rate stays right up at the maximum. Now, after a week of this, you take animals from the first group and you deprive them of food for 24 hours. You now put them in a maze that has food in the goal box. And what happens? Sometimes within the first hour's test session, always by the second, their error rate drops to the point achieved by the other experimental group that had had reinforced exposure in the maze for a period of a week. Now let me rehearse the finding. The finding is this. Animals who in the course of a week had exposure to the maze an hour a day, no reinforcement, no hunger, no food deprivation, showed a very high error rate. They were then placed in a maze after being deprived of food, to use anthropomorphic language, after being made hungry. And under those conditions, the goal box now had a food bait, had a reward, a reinforcer in it. These animals, within an hour's training session, have dropped their error rate to what was achieved by the experimental group that had been reinforced every day for every successful run, an hour a day for a period of a week. The conclusion Tolman must reach is that, in fact, both groups of animals were learning the maze. However, one group was not revealing what was being learned in the maze. Now, what kind of learning, Tolman says, was taking place? Well, Tolman gives us a term for this: latent learning. And this is a key term in the cognitive psychology of animal behavior. The organism learns as a result of exposure, just as we saw in Tolman's other studies. Learns as a result of exposure to the environment. The function of reinforcement, then, is not that it's necessary for learning to take place, but that it contributes significantly to performance. And Tolman wants to make the distinction between learning and performance. Learning arises from experience. Performance very often requires motivating conditions like hunger and a food reward. Now, we can tie this in with studies of human subjects. I mean, these tie in directly with human intellectual achievements and problem solving in general. But let me offer the example of studies involving what's sometimes called mental rotation. Here's the task. One might hold up an object and rotate it in space. You might have a little fan-like object that turns around, and you can vary the rate at which it turns around. Or you might hold up a cube and rotate it around an axis. You show people that the cube is rotating around an axis. You now ask the percipient, once you've removed this stimulus, to imagine the stimulus. In fact, to form a mental image of this. And to try to form a mental image of this rotating at the rate at which you presented it rotating. And you might ask the person to tell you now, to indicate by tapping a key or saying now and the like, when a certain number of rotations has taken place. It turns out that subjects quite reliably and quite accurately can mark off the periods of time that mentally rotated objects must be rotating to achieve some criterion level. They will tell you during debriefings that, in fact, in a manner of speaking, the way they do this is by picturing the object, picturing its dynamics, and then estimating the duration of time or the number of revolutions and the like through this inward-looking process. They have an internal representation of an external event. They're engaged in a process that is not perceptual, so to speak. It's not a process involving objects in the external world. It is to some extent memorial, but it is centrally representational. And when we ask what kind of representation is it, well, if we're not too sheepish about the use of the English language, we'd be inclined to say that it is a mental representation. It's a mental representation in just the way that the rat is forming some sort of mental or cognitive map. Now, Tolman was not a superstitious person. He was an experimental scientist. And when Tolman talks about a cognitive map, he doesn't think that if you open up the animal's cranium and look inside, you'll see something that the Mobil Corporation or the AAA would distribute as a map. Rather, what Tolman is saying, what Curler was saying, what the whole Gestalt tradition was saying, is that the external world does become represented within the organism and within the nervous system of the organism. The nervous system must be configured in such a way and functioning in such a way as to be able to preserve the relevant details of the external world when that world is no longer present. Otherwise there could be no memory, indeed otherwise there could be no learning, and surely there could be no problem solving. So we have moved in the direction now of a cognitive science. We haven't abandoned behavioral psychology, but we've absorbed animal behavior into a more dynamic and, yes, indeed, mentalistic framework.